Welcome everybody to this month's Pacific Northwest Drought Early Warning System Drought and Climate Outlook webinar. My name is Jason Gerlich and I am with NOAA's National Integrated Drought Information System. This bi-monthly webinar series is hosted by NOAA's National Weather Service, NIDIS, the USDA Northwest Climate Hub, and the Oregon Climate Change Research Institute. It is designed to provide the Pacific Northwest with timely drought and climate information. Each webinar is tailored to reflect recent, current, and forecasted conditions and climatic events. Observed impacts and other relevant updates from across the region will also be included. The recording and other supporting materials will be posted on drought.gov after the webinar. Today's speakers are as follows. For the climate recap and current conditions, we have Jacob Genuise with the Washington State Climate Office. For seasonal conditions and climate outlook, we'll have Brad Pugh with the National Weather Service and Climate Prediction Center. We'll have, for our presentation on the Pacific Northwest Water Impact Survey, we'll have Karen Bambacco with the Washington State Climate Office as well. And then at the end, there will be time for Q&A after each presentation. If you could also go ahead and try to find the Q&A box there at the bottom of your screen, you're more than welcome to submit your questions there as well. Before we begin these presentations, we want to make sure to highlight the partners who make this webinar series possible. The Northwest Climate Hub develops science-based region-specific information that will assist agricultural and natural resource managers with climate-informed decision-making in Idaho, Washington, Oregon, and Alaska. OCRI, or the Oregon Climate Change Research Institute, is a network of researchers at Oregon's public universities who work with public and private entities to advance understanding of regional climate and climate adaptation. OCRI is administered by Oregon State University and hosts the Oregon Climate Service, the Office of the State Climatologist of Oregon. And you can find in the chat more information on each one of these organizations. NIDIS was established in 2006 by public law with a mandate to provide the best information and resources available to assess the potential for drought and to better prepare for, mitigate, and respond to the effects of drought. NIDIS maintains a drought early warning system where a network of partners provide information and actions that help communicate and cope with drought across the regions. You can stay updated on conditions in your state and local areas with the U.S. Drought portal. To facilitate the early warning system, more precipitation observations are needed. We encourage you to join COCORAS, the Community Collaborative Rain, Hail, and Snow Network. COCORAS is a unique, nonprofit, community-based network of volunteers who work together to measure and map rain, hail, and snow, and to report conditions. To become a volunteer or to learn more, you can visit cocoras.org, or you can contact your state coordinator with links in the chat box. Understanding how drought impacts you is important for drought assessment at the state, regional, and national levels. The National Drought Mitigation Center Condition Monitoring Observer Reports, or CMOR system, is a great way to submit the impacts you are experiencing from too much or too little water. This information becomes accessible to those who assess drought in your state. For drought monitoring purposes, and this information is also used to support the Pacific Northwest Water Year Impacts Assessment. More information, again, can be found in the chat box. Some news from around the Pacific Northwest Drought Early Warning System. The first snow drought update of the season was released last Thursday, as the snow season is off to a slow start across the West. More information will be provided in today's presentation, but I wanted to make sure to emphasize that the annual Pacific Northwest Water Impact Survey is open until the end of today. We hope you will take 15 minutes to fill out this survey. Lastly, if you want to receive the recording of today's webinar and other pertinent information from around the Pacific Northwest Drought Early Warning System, please follow the link in the chat to go ahead and sign up. And with that, we will now transition into our first presentation, and that will be, again, Jacob Genuise with the Washington State Climate Office. Please go ahead to start sharing your screen. Thanks, Jacob.
Thank you so much, Jason. Let's see. Okay. So everyone, I'm Jacob Genuise. I'm an engagement climatologist with the Washington State Climate Office, and I'm going to be giving kind of an update and a recap of our recent climate conditions and then talk a bit about our current climate conditions as they stand today. And I'm from the Washington State Climate Office, but I'll be talking broadly across the region. So we'll start with a review of water year 2025, just a brief kind of look back at what the previous year has brought up through October. Then we'll take a closer look into recent conditions since August of this year and kind of talk about how that's led us into our current conditions and what we're seeing right now across the region. So starting with the water year 2025 review, if you can think back, this isn't current snowpack, but this is snowpack as of April 1st of this past year. So kind of where did we start out heading into the dry season in the Pacific Northwest? This is showing snow water equivalents, the amount of water that's held in our snowpack as of April 1st, 2025. And the dark blues down in Oregon show areas of well above normal snowpack, also areas of western Idaho. And then we have near normal snowpack in these kind of green and light blue colors is areas of western Montana, the Central Cascades, and the border of Oregon and Washington. And then we had some below normal snowpack areas up in the northern Cascades in Washington as well. And then leading into kind of spring and summer period, these two maps are showing percentile of temperature on the left and percentile of precipitation on the right for the April-September period. And you can see that we have some record warm temperatures in these darkest oranges and some record low precipitation, so record dry areas in these dark brown areas in the rightmost image. And so you can see that really all across the region, we were experiencing these warm and dry conditions. And notably, there's some overlap in some key regions between the record warmest and record driest areas. So in the Cascades and northern Idaho is really where we saw both very warm conditions and very dry conditions kind of coupling up. Some of these warm conditions in the late spring led to earlier than normal snow melt out, which was pretty crucial. And then these warm and dry conditions throughout the rest of the summer through September increased demand, increased evaporation, and just overall led to drought conditions across the region. And so looking at how the drought monitor stood as of September 30th, towards the end of the summer, beginning or kind of end of the dry season, you can see that drought really took hold across much of the region. These are the areas of any orange shading here is drought, and then the yellow is abnormally dry conditions. So you can see that really large swaths of the region were experiencing these very dry conditions, notably the northern Cascades, parts of northern Idaho, southeast Washington, and western Montana had exceptional drought. Extreme drought and then exceptional drought, the darkest red here in northern Idaho showed the worst drought conditions across the region. So really expansive drought everywhere except for kind of south central Oregon was experiencing drought. And putting this into some long-term context, it wasn't just 1 year of drought, but if we look back at the past 36 months, this is an indicator called SPEI, which is the Standardized Precipitation and Evapotranspiration Index. It's a measure of dryness across the region, and mapped here is the past 36 months. Red colors are showing where the driest conditions occurred, and blue colors are showing where wetter conditions occurred. And we can see notable dry areas across the Cascades in both Washington and northern Oregon, northern Idaho as well, and western Montana. So really crucial snowpack regions have been experiencing drought for quite a long time, not just this year itself. So zooming in kind of to the late summer period into fall of this year, if we look at monthly precipitation and temperature, these values are for Washington, Oregon, and Idaho combined. And so on this kind of leftmost column in this table, we're looking at temperature rank. So August, September, October, November. Generally, the trend here was warmer than normal temperatures. In August, we had the sixth warmest August on record, about 4 degrees above normal on average. September was a record warm month for these three states, about 6 degrees above normal on average. October came in around near normal, slightly below with about a degree below normal, but given like long-term records is pretty close to average. And then November came in as the second warmest month as well. So taken all together, this August through November period was the record warmest on average across the Pacific Northwest. The rightmost column here shows precipitation. And you can see that really August, September, and October had just about near normal, some slight fluctuations, but when you average across this area, pretty close to normal. And November was a bit drier, kind of in the bottom third of all years, about an inch below normal across the region as a whole. So these are averages, as I said a couple times here, right across the whole region. And if we look at a map to kind of show spatial variation, we do see some differences here that are important to note out. So this is the last 90 days, and looking at the leftmost picture here, this is through September 12th through about December 10th, so just a few days ago. And you can see that the story here is kind of wet in the north and dry in the south. So we're seeing in these green areas, these are areas with above normal precipitation, and the brown areas are areas with below normal precipitation. So these areas across, southern and central Oregon, the Snake River Valley, is really where we're seeing these deficits start to emerge. And then as far as temperatures go on the right side here, we're seeing really warm conditions pretty much everywhere across the region, about 2 to 4 degrees above normal for most spots region-wide. If we look in a little bit more recently, so the last 30 days, we see this pattern continue, right? So we're seeing that wet in the north, dry in the south pattern as far as precipitation goes. Much of this circled area has seen less than 50% of normal precipitation. And it's notable that, we're still in early winter, so these precipitation patterns could change and likely will. But these deficits also become harder to overcome as we head through December and into kind of midwinter. And temperatures have been really, really warm over the past 30 days. To be a little bit more technical with it, about 4 to 7 degrees above normal for most areas. And this is region-wide. We haven't seen any areas in the past 30 days that have been below normal, so it's been quite warm. If we put this into some longer term context, so this is those kind of same data, we're looking now and comparing them to previous years. So in 131 years of record, our September to November, so kind of that fall period precipitation rank on the left here. These lighter brown colors are in the driest third of all years, so much of Oregon where we saw those deficits on those previous few maps. That's where we're seeing those drier than normal conditions. It's not record breaking, but it is notably dry in these areas. And temperatures, on the other hand, have been record-breaking across huge portions of the region from September to November. So eastern Washington, eastern Oregon, the entire state of Idaho, western Montana, all these areas have seen record warm conditions during this period. And outside of those record warm regions, we're still seeing warmer than 90% of all years, temperatures that have been warmer than 90% of all years across western Washington, western Oregon, and really region-wide, we're seeing this warmth. So what does this mean for current conditions? What have we seen recently? You've probably seen on the news, or if you live in Western Washington, you've experienced some of this firsthand. We've had some pretty bad December flooding, some really persistent atmospheric river that's dropped quite a bit of rain. So in the shorter term here, we've seen rivers reach major flood level. So this image on the left here is showing major river gauges. The purples are showing rivers that have reached major flood levels. We've seen some record-breaking flooding as well. This graph on the right is for the Skagit River up in northern Washington, so right about here, if you can see my cursor kind of circling. So we've seen record-breaking stream flow there and some really impactful flooding, and you can see some photos of some of this flooding up above. So really impactful event, kind of shorter term. And so what does this mean for water resources across the state? As we know, and we've seen this with this event, atmospheric rivers can be really destructive in the region, but they can also bring benefits, and they often do both at the same time. So this graph here is showing Yakima River basin storage, and you can see this blue line is the current year. This red kind of dotted line is the average basin storage. And then this green line, this green dashed line is last water year's storage. And so you can see this blue line showing current year conditions. We've seen a huge increase in the amount of storage in this reservoir as we've seen this really warm, rain-dominant atmospheric river event that's just dumped a lot of water that's flown directly into reservoirs in the past few days. So although we don't want to deal with the flooding, it is nice to get so much water so quickly, or so much water. We don't want it so quickly, but it is nice to get this much water to kind of fill some reservoirs and boost them back to near normal. But it is notable that last week's storm, as I mentioned, was quite warm. And so we got all this rain that ran into reservoirs. But as far as snowpack goes, we have not seen really any boost and actually a decline in snowpack across the region. So this graph is showing snow water equivalent across the entire Pacific Northwest hydrologic region. And this black line is showing the current year. This green line is showing our average, where we should be at this point in the year. And then the kind of shaded colors show different percentile ranges above and below that. So the blues and greens are what you might think of as good, right? A healthy snowpack, maybe even above normal in those blues. And then the yellow and red show below normal snowpack. And so this black line, you can see the atmospheric river event came in right about at this peak. And given all this warm rain, it actually melted some of our snowpack and we saw a decline. And region-wide, we're seeing snowpack that's sitting at the lowest on record for the region as a whole at this point in the winter. So it's still pretty early in the winter. We could see this change, and this is likely to change as we see some wetter and cooler systems later in this month, but we're definitely sitting well below normal as we talk here today. Looking at how this breaks down spatially across the region. This is also showing snow water equivalent, and so a measure of snowpack. This is as of December 11th, and you can see that in these reds, this is any areas that have snowpack below 50% of normal. So large areas, really all of Oregon and southern Washington, seeing really, really deep snowpack deficits. And the only places where we're really seeing near normal snowpack is out in western Montana. But it's important to note here that the kind of causes of this snowpack deficit differ a little bit across the region. So in Washington, we've seen just a lot of really wet storms that have dropped a lot of precipitation, as we saw. There's above normal precipitation for the past 90 days, but they've been warm, so it hasn't been translating into snowpack. But down in Oregon, we've seen similar, the storms they have gotten have been quite warm and dropped a lot of rain, but not a lot of snow. But then in addition, we've had those snowpack deficits across southern and central Oregon and parts of the Snake River Valley. And so it's not only the warm storms, but it's also these precipitation deficits that are leading to the snowpack kind of problem as we head into the cool season here. We expand north to British Columbia. We're seeing kind of a similar pattern here. I just want to note these data are a little bit old as of December 1st, but they're pretty representative of where we're at now as well. And you can see these coastal ranges in far southwest BC are quite a bit below normal. And this is a similar reasoning as to the Washington deficits we're seeing, just really warm storms with a lot of rain and not a lot of snow. You might expect if we've seen all this rain that's been able to run directly into soils and into rivers, you'd expect soil moisture to also be quite a bit above normal in these areas. And we can see that reflected here in these dark blues. These are where we're seeing above normal soil moisture percentiles, really across western Washington, northern Idaho, western Montana, where we've seen those wetter than normal conditions. And those deficits in Oregon and precipitation we're starting to see emerge in soil moisture as well. So you can see notably kind of along the coast in far southwest Oregon, Northern California, and then pockets of the Snake River, River Valley as well. We're seeing these soil moisture deficits too. It's kind of interesting to note too that it's actually helpful that we've seen some soil moistening up in the Cascades in Washington and northern Idaho and western Montana. Even though we don't have the snowpack yet, it's very helpful to have saturated soils and then hopefully get some snowpack built up on top of that throughout the rest of the winter. And then when spring snow melt season comes, as that snow melts, it doesn't have to sort of moisten the soil. The soil is already saturated from these early season rains and can hopefully run directly into rivers. So this could be helpful for us later in the spring, but that's all dependent on how our snowpack situation really shakes out for the rest of the winter. Looking at reservoir storage down in Oregon, we're seeing, I kind of circled and highlighted a few notable Western Oregon reservoirs that have seen some really big drawdowns in the past month. So you can see this kind of leftmost arrow and number here is showing the change month over month, and then the kind of rightmost figure or rightmost data point here is showing the change year over year. As you can see for this Green Peter, Detroit, and Lookout Point reservoirs, there's been really big drawdowns just due to this precipitation deficits we're seeing and just still existing water needs. I also noticed there is some increase in some of these Eastern Oregon basins, and I'm not exactly sure what's driving that, but I would gather that it's related to just these warmer storms. So when they have gotten rain, it's able to kind of run off and not stay as snowpack. But we'll have to see how that shakes out for the rest of the season as well. And these are also as of December 1st. So just noting that data is a little bit lagged here too. So recapping kind of this whole discussion here. So multi-year drought is placing long-term drought pressure on water resources. We saw over the past 36 months that we've seen this drought pressure. We've seen a fall period that's been record warm across much of the region. Despite areas of above normal precipitation, we've seen warm storms that have not dropped a lot of snowfall in our mountains. So we have below normal snow water equivalent or snowpack in Washington, Idaho, Oregon, and Southwest BC. And we're seeing growing precipitation deficits in southern and central Oregon, which are further limiting snowpack growth there. And the one exception here is western Montana, which has near normal snowpack. It's just been cold enough to allow for this precipitation to fall as snow there. And the recent flooding event in Washington has boosted reservoirs, which is really helpful, but we did not see it improve snowpack. We have some additional precip coming in this week and hopefully into the kind of later half of the month. And it does look a bit cooler, so we're hoping to get some snowpack out of these storms to come, especially in the northern Cascades. And also, as I mentioned, saturated soils should help our snowpack run off in the spring, really run off efficiently into rivers. So we're hoping that if we can build up some good snowpack, this kind of early season rainfall has been beneficial in that way. And that's all I have for y'all.
Awesome. Thank you so much, Jacob, for that briefing. We will now transition over to Brad Pugh with the National Weather Service.
All right. Thank you, Jason. I'm Brad Pugh, meteorologist at the National Weather Service's Climate Prediction Center. And my presentation today will be on the latest climate conditions and also outlooks for INSO, temperature, precipitation, and drought. So starting off here with the average sea surface temperature anomalies on the left-hand side. You can see we have below average SST anomalies across the central and eastern equatorial Pacific. And this is valid for the past 4 weeks, so November 16th through December 13th. And on the right-hand side is OLR anomalies. And the purple shading, the negative values, that equates to enhanced rainfall, and then the kind of the orange brown shading closer to the date line, that's more suppressed convection or rainfall. So this wetness over the maritime continent and the suppressed rainfall near the date line, that's very consistent with an ongoing La Niña. And next slide here is the how the SST anomalies have changed over time. So this goes back, the time series here goes back one full year. You can see how the SST anomalies have declined during the summer and early fall. And in the Niño 3.4 region, and on the left-hand side, you can see the region there is in the east central equatorial Pacific. So the negative anomalies peaked in mid-November. We did have the enhanced phase of the Madden-Julian oscillation across the Pacific that brought a relaxation of the easterly anomalies near the date line, and we actually had SST anomalies bump up a little bit to minus 0.4. Recently, though, they have trended back down. So the latest weekly departure in the Niño 3.4 region is sitting at minus 0.7 degrees Celsius. So next slide here is the forecast for ENSO as we move forward in time. And as we go into January, February, March, so the forecast does call for higher probabilities of ENSO neutral conditions. So we're expecting a transition to ENSO neutral conditions during this 3-month time period of January, February, March. Probability of 68%. But we do expect La Nina to continue over the next month or two. And even beyond that time, we could have a lingering influence on the circulation pattern in the atmosphere across North America. Here's the U.S. Drought Monitor. This is valid last Tuesday, December 9th. So we still have some lingering D1 moderate drought over portions of Washington and Oregon. And as Jacob noted, snow water equivalent is very low right now. Many of the river basins here in Washington and Oregon, well below 50%. It's been a slow start to the snow season with dryness over southern Oregon, and then the warmer than normal conditions farther to the north over the northern Cascades of Washington. This is early in the season, and we do expect snow levels to fall over the next few weeks as we see a parade of Pacific storms. So should begin to see a increase in the snowpack as we head into the new year. So the past 7 days, as Jacob noted, it's been very wet there over western Washington. We had the major flooding. Precipitation amounts exceeded 10 or even 15 inches during the second week of December. And these are real-time stream flows from USGS, daily stream flows. So we have record highs in parts of Washington, but fairly low as you move your way down into southwestern Oregon. So looking ahead here at the forecast, this is the 7-day precipitation forecast from the Weather Prediction Center. So this is valid December 15th through the 21st. And we are expecting additional heavy precipitation during the next week over the Pacific Northwest. Locally, amounts could exceed 10 inches over western portions of Washington and Oregon. And since last week, the Climate Prediction Center has been releasing a key message detailing the stormy pattern there in the Pacific Northwest coming up here during the remainder of December. So yeah, please check our website for additional forecast information, as this will be updated later this afternoon. So moving to the week 2, 500 millibar heights and anomalies. This is valid December 22nd through the 28th. And this is the forecast from yesterday. And we have a very stable long wave pattern over the North Pacific and North America. And it's very consistent with the La Nina pattern, with this highly amplified ridge over the Aleutians, downstream troughing over the northeastern Pacific, and then this broad anomalous mid-level ridge over the southern lower 48 states. So yesterday's week 2 outlook, valid December 22nd through 28th, was favoring above normal precipitation throughout the western U.S. The highest above normal precipitation probabilities were focused farther south over northern and central California, where probabilities exceeded 70%. Probabilities did taper off a little bit over Washington and Oregon, but they're still fairly elevated. between 40 and 50%. And of course, this is a wet time of year. If you look at the temperature outlook on the right-hand side there are some signs that temperatures may begin to cool as we end the month. During this week 2 time period, we are slightly favoring below normal temperatures, especially for northwestern Washington. Farther to the south, though, over southeastern Oregon, above normal temperatures are more likely. And this forecast will be updated 4 o'clock Eastern time this afternoon. We also release a weeks 3-4 outlook each Friday, and this is the week 3-4 outlook that was released last Friday, December 12th, valid from December 27th through January 9th. So this takes us into the new year. There's signs that the wet pattern is going to persist across the Pacific Northwest. Pretty high probabilities for our week 3-4 outlook, with probabilities exceeding 50%. And for temperatures, equal chances for below, near, or above normal. All right, so the final few slides here will be on our seasonal outlook, January, February, and March. We do expect La Niña to continue to provide a influence on both temperature and precipitation. The temperature and precipitation outlooks were based on dynamical model guidance, such as the North American Multi-Model Ensemble, NMME, and also the Copernicus Ensemble prediction suites, both bias corrected and calibrated, and then also statistical tools linked to predictors such as ENSO and sub-global relationships between key variables such as sea level pressure, upper level heights, and sea surface temperatures. Also considered both positive and negative long-term temperature trends and coastal sea surface temperatures. So here's the temperature and precipitation outlook for January, February, March. This was issued last month, so this will be updated. Actually, this just a few days from now on Thursday, December 18th. So 1 month ago, we were favoring below normal temperatures for most of the Pacific Northwest. Probabilities generally between 40 and 50%. And there's a nice little pie chart here in the upper left-hand corner. So see, there's still a 33% chance for near normal temperatures, or 21% for above. But the most likely category during this 3-month time period would be for below normal temperatures. And then we have equal chances of near, below, or above normal precipitation. And once again, this was a forecast from last month and may be modified in the release coming out on Thursday. And the seasonal drought outlook, calling for drought improvement and removal likely for the Pacific Northwest. We'll be closely monitoring snowfall later this winter and as we head into the spring throughout the West. And our seasonal drought outlook will be updated also on Thursday morning, December 18th. All right, so yeah, just a few key takeaways here. Wet pattern with likely additional heavy precipitation and a flooding risk. We're expecting that to continue for the Pacific Northwest into the new year. So yeah, very stormy pattern coming up over the next 2 to 3 weeks. Drought is forecast to improve or end in the coming weeks or month, but there is some concern here with snowfall due to the slow start to the snow season. Temperatures are likely to be highly variable, but over the averaged over the 3-month time period, January, February, we are expecting below normal temperatures, but probabilities are just slightly elevated. And yeah, that's it from CPC. Thank you.
Awesome. Thank you so much, Brad. Thank you for that great presentation. And our last presentation of the day will be Karen Bombacco. Please feel free to go ahead and share your screen. Thanks, Karen.
Thanks, Jason. All right, hopefully that looks okay. Good morning, everyone. My name is Karen Bombacco. I'm with the Washington State Climate Office, so colleagues with Jacob, and we're part of the University of Washington. And today I wanted to talk a little bit about the Pacific Northwest Water Year 2025 Impact Survey. So if you scan that QR code, it'll take you directly to the survey, which we is in Qualtrics. So it goes to a Qualtrics link. Although I saw in the chat, there was already a couple times it's been pasted in the chat for the survey. So this is some work I've been doing with my colleagues here at the Climate Impacts Group and at the Washington State Climate Office, Lisa, Becca, and Guillaume, and then also with Larry O'Neill and Erica Fleshman from Oregon State University. And so what we're trying to do for the past 5 years, we've been writing these Pacific Northwest Water Year Impacts Assessments. So what we try to do with these is document the water year impacts and link them to the water year conditions. So, unusual weather events. I can guarantee that next year's 2026 assessment will have more information about the flooding that has just occurred in Washington, but linking those water year conditions to the impacts, and we're looking at it by sector. So ultimately, we want to try and better document these impacts so that we can be better prepared for future change. So we've had 5 of these assessments already. And this work is funded by NIDIS, and we're starting to write our 6th assessment currently. But as a part of that, we ask people that reside in Washington, Oregon, and Idaho to help fill out our water year impact survey. So as a reminder, this is going back to just the 2025 water year. So it's getting later in the 26 water year right now, but we're still asking for folks to think back and remember from October 1st of 2024 through September 30th of 2025. And what we're trying to do is gather information about those impacts and response actions due to either abnormally dry conditions or abnormally wet conditions. So for 2025, for a majority of the Pacific Northwest, those reports have been about abnormally dry conditions. And then we're connecting those to sector-specific impacts to help inform planning, response actions, technical and scientific information needs. So we left the survey open a little longer than usual this year, just because with the federal government shutdown, we weren't able to get some of our federal partners to help spread the word about the survey. So I'm closing it at the end of today. So it's one more day to have your chance and get your impacts heard. And the audience for this survey is tribal, local, state, federal agency staff, and people that are working within the water, agricultural, forestry, fisheries, hydropower, or recreation sectors. So the way we set up the survey is if you work in agriculture, for example, you're able to skip the 6 other sectors and just fill out that portion of the survey. So it does take usually about 15 to 20 minutes to fill out the survey. So not a huge lift. And it might look daunting at first, but once you're clicking to pass through these other sectors, it does go pretty fast. So as of Friday, we've had 340 responses. We have more of a response from Washington. So that's on the left-hand side, this bigger piece of the pie in the purple, and fewer responses from Idaho. Is probably twofold. As the survey maker sitting in Washington, I think our outreach might be a little bit better across Washington state, but also for 2025, the drought and the drought impacts were more severe in Washington. So it sort of aligns with what we had seen for the 2025 water year. And then responses broken down by sector as of Friday. Our biggest slice of the pie is agriculture, followed by forestry and drinking water, and then fisheries is behind. So fewer responses from hydropower, recreation, and stormwater. And then I haven't dug in yet to really understand what this other portion is yet, but we will be doing that shortly once our survey is closed. This is just a reminder. I think actually Jacob showed the same plot. So this was where we were on the US Drought Monitor at the end of the 2025 water year. So as you can see, sort of this northern section of the Pacific Northwest had more severe drought in place at that time, and is hence why maybe we're getting more responses from at least Washington for the survey. So I just wanted to do a sneak peek into some of these survey results. Again, this was just, a quick grabbing of some results as of Friday. We have not dove very far in depth in our results yet, as the survey is still open through the end of today. But this is looking at what people selected that filled out the agriculture part of the survey, which was the most number of respondents in terms of what impacts they were seeing for the 2025 water year. So not surprisingly, less surface water and stream flow, reduced crop yield, increased plant stress, water right curtailment, or a reduced amount of water allotment. So those are sort of our top 4 responses, and then it goes down from there. So I did an initial parsing of those responses to try and understand, well, where was this happening in the Pacific Northwest? A majority in Washington, which again makes sense considering the drought conditions, and then fewer in Oregon and Idaho. But what we're going to do this year is really dig into that geographic question. And I think we've got some much better data in terms of where the impacts were experienced. So we're hoping to break this down at the county level. And then importantly, 46% or 46 of the agricultural respondents said that they actually changed their operations or practices in response to these dry conditions. And so then we also have a series of questions asking like, well, what did you do to prepare for it? Or did forecasts play a role and help you make those decisions earlier than you otherwise would have? This is a really complicated graph. We'll figure out a much better way to present it in the assessment report, but we also were trying to drill down at which crops were impacted. And so okay, I'll walk you through. So there's 2 axes just because these bars are small. But this top one, for example, is just you have each person that filled out the agriculture section had to select whether pasture was negatively impacted, positively impacted, or not impacted. So these are the colors here. So we see a large number of respondents saying that there were negative impacts to pasture, hay, wheat, cereal grains, and orchards. So we're digging into this a little bit to try and understand what crops were impacted by dry and both wet conditions. I'm not showing the wet just because we have fewer responses, but we'll have all that in the final assessment report. This is the same sort of slide setup, but looking at forestry. So the highest impact for forestry was tree mortality, more insect activity, and leaf or needle drop, sparse canopies, etc. This is a split about evenly between Washington and Oregon as far as where these impacts were seen, and then we had 8 responses from Idaho, so fewer in Idaho. 26 of these respondents said that they were changed their practices in response to these dry conditions. So looking forward to digging into that a little bit. So I wanted to just show this briefly. This is from last year's assessment. So looking at the 2024 survey, and this is showing where the impacts were reported, or the highest number of impacts is kind of this darker green area. And this is for both dry and wet over the whole period of the water year and for regardless of sector. So we saw that the eastern slopes of the Cascades, parts of the Olympic Peninsula or in Washington, more so in northern Idaho, and then in southwestern Oregon had the highest number of impacts last year. So we're hoping to drill down and get even more refined maps with this year's survey responses, and perhaps making this for each sector that we have data for. This came out really blurry, but if you look at the 2024 assessment report, it looks much nicer in person. And this is just an example of what we reported in last year's assessment. So going through and showing the percentage of each of these impacts for both dry and wet. This is recreation from last year. And then this is a snapshot of fisheries. So, things from impacts from wet conditions, for example, something like high sediment loads, poor water quality, etc. So with that, I'll close. I just wanted to give a whirlwind, um, introduction to the impact survey. And if you have your survey in progress, there's still time to finish today. Like I said, we'll be closing it at the end of the day so that we can start analyzing these results. And like in previous years, we expect the 2025 impacts assessment to be out sometime in March. So you'll be hearing from us when that report is complete, and some of you sooner for reviewing material that goes into that. So with that, I'll close. Thank you.
Karen, there was a question
Thank you so
about,
much,
is
Karen.
end of day midnight or is it 5 p.m. Pacific?
We can go till midnight. I'm not going to be analyzing results at 8 p.m. tonight, so that's fine.
Awesome. Thank you, Karen. We have about 14 minutes left in this webinar, so thank you to all the participants who are still online. If you have any questions, this is a great time to go ahead and put them into the Q&A chat box. And with all of our panelists still in attendance, we will do our best to answer those questions.
There was a question that perhaps either our panelists or one of the other organizers could address about the current sea surface temperature anomaly seems to be fairly high.
I can address that a little bit. So yeah, right now we have a marine heat wave in the North Pacific, and we've kind of had it since back in at least July or August. And I did provide an answer on it. And so basically the question is whether whether it's contributing to our warm start and low snow here. And it probably is contributing some, but the atmospheric circulation pattern right now, we've had this broad ridge over the Eastern Pacific for quite a while, and that's been bringing a lot of warm and moist subtropical air, which is both causing the marine heat wave and then also contributing to our warm start to the year. So the marine heat wave might be a consequence of what we're seeing right now rather than a cause.
Thanks, Larry, for that clarification. Any more questions from the audience? Elliot, yes, there will be a recording of the webinar that will go out to the Drought Early Warning System listserv once it has been processed. And it'll go directly to your inbox. The webinar recording can be found on drought.gov, as well as a link will be provided in an email after this webinar. Maybe here's another question for one of our panelists. The ENSO forecast shows increased probabilities for El Nino next year. Are ENSO forecasts made so far in advance? How useful can they be viewed? sounds more of a probabilities question. Maybe Brad, you could help.
Yeah, sure. Yeah, going out that far in advance. Yeah, you have to be careful. And if you look at the probabilities, going into next summer, they're pretty much evenly split between INSO neutral and El Nino. Just yeah, pretty close to 50-50. So.
We have a question here from Alex. He would ask us to help contextualize what does the warmest August to November in 131 years mean?
Good thing I can take that one. I was just trying to pull up a time series of what has happened in the past to kind of answer that question. But yeah, it's definitely not good. And it's definitely, the warmest in 131 years is pretty anomalous. Just for some context, so the temperature that produced that anomaly in the Pacific Northwest was around 54.3, and that's quite a bit warmer than our like 1991 to 2020 kind of average. And I can find that actual number to compare for you in a moment. Yeah, so our mean for the 1991 to 2020 period is about 51.6, and this past year it was 54.3, so that's that above normal by about 3 degrees there. We've had some warm periods in the past. For example, 1966, we had an average temp of 53.4, so that was well above this kind of more recent mean. So it's definitely quite warm, but we do see year-to-year variability. But it's been on a warming trend, and the past few years have also been above normal too. So we've seen much more above normal years in the past few decades than we did in the past. Hopefully that provides a little bit more context, but definitely anomalous and definitely quite remarkable to see the warmest period in that long of a record. And it's kind of a example of how it's nice to have these long-term records to be able to compare for that long.
All right, quite a few questions come in. We'll do our best to get to them with the time that we have. Great question from Justin. Maybe one of our panelists can help. So his question is, with the water currently being held in the reservoirs due to the significant atmospheric event, river event over the past couple of weeks, can that help ameliorate some of the issues that may come about from a lower snowpack year? Or will the meltout be so reduced that it won't necessitate the release of water currently being held? So maybe we can help him contextualize that.
I can help with that one, I think. Jason, Jacob, if you want to chime in. Sorry, I was rereading it a few times. So I think it's a complicated answer just because it depends on how each reservoir is managed. So, some have to manage for flood control, so they're not able to keep that water level really high moving forward. And they'll have, like on the west side of the Cascades, they'll have to release some of that water. But on the other hand, it is good news for the spring because then that means that they'll be able to release, like in the Yakima, be able to release that water before the snow melt contribution comes into the reservoirs, or at least to make sure they have enough room from the snow melt contribution, if that makes sense. I feel like I'm not describing this well. But Jacob, did you have something to add?
Yeah, no, that was great. I think I was just going to add that they take snowpack into account, when they're determining how much to let out to prepare for the snowmelt, right? So if it's still really low in the spring, they might not have to release as much to kind of prepare for that. So they manage it actively depending on conditions too, just like Karen was saying. So yeah, and I agree, it depends dam by dam, and yeah, so.
Awesome. Thank you, guys. The next question we have here is, if we do not get substantial snow for our snowpack soon, at what point or data points do we look at to assume that we could go into drought conditions, excuse me, into the next growing season?
Yeah, I can take that one too. I think that's another really variable one. Oh, I see. Oh no, Larry's not answering that one. Um, just depending on where you are in the Pacific Northwest, but for Washington, it's a little too early for December to be really worrying about spring snowpack. Like, we tend to get snow at this point, so those record low percentiles mean something. But overall, December, January, February are pretty big months for building snowpack accumulation in our mountains. So I would say it's more like assessing the situation in February. We're getting more concerned. If it was still this low, we would be very, very concerned if it was later in the season, if that helps kind of answer it.
I think so. Thank you, Karen. Next question here is it reasonable to assume that low snowpack may be bad in terms of creating a late summer drought next year?
I think it's also, again, a kind of complex answer, right? But it depends, right? If we get a ton of rain and reservoirs are able to fill up, then maybe it's not as big of an issue. So it'll really depend on that kind of late winter period. But if the snowpack is still bad in the spring, especially given these multi-year drought pressures, right? Like even if we had sort of near normal water year precipitation or winter precipitation, then we could still have issues based on kind of reservoirs being still low from previous drought as well, and just ecosystems needing to recover. And so it's complicated again, and low snowpack would definitely raise concerns, but there's other factors as well that might indicate drought as we head into the summer. And yes, thanks, Josh. He just noted that don't forget about us over here on the east side of the Cascades. So totally agree. And forgot to mention that there's flooding on the east side of the Cascades as well from the atmospheric river event. So definitely we don't forget about y'all. I appreciate that.
Thank you, Jacob. All right, we'll probably take one or two more questions. Give it a few more seconds here. All right. Seems like we've hit a lull in more questions coming through. Thank you to all of our panelists for your time today and your presentations at today's webinar. We greatly appreciate your efforts to communicate conditions across the Pacific Northwest. And thank you to all of our participants for attending today. We hope that you took away some valuable information from today's webinar. We look forward to seeing you at the next one in February. And I hope you have a very happy holidays and a very good new year. And have a wonderful rest of your day. Thank you.